Welcome in everybody to another lesson. Today we are going to talk more about the coordinate system, also known as the coordinate plane. So again here you have what's called the coordinate plane, where when it runs from left to right you have what's called your x-axis, which runs from left to right. Then you have your y-axis, which runs from top to bottom. So it's made up of the x-axis and the y-axis. Now, the coordinate system is also split into what's called quadrants. So, the quadrants go counterclockwise. The top right is the first quadrant, the top left is the second quadrant, the bottom left is the third quadrant, and the bottom right is the fourth quadrant. It goes counterclockwise. So, we got first quadrant, second quadrant, third quadrant, fourth quadrant, okay? Now, part of today's goal is, half of it really, is to be able to plot points and then know what quadrant it lies in. So let's get started with our first one here. You're being asked to plot the point 4, 5, right? You want to locate the point 4, 5. So what you're going to do, this tells you your x coordinates 4, your y coordinates 5 on this ordered pair 4, 5. So first thing to do is go over to the right 4 from the origin. Always start the origin. Go over to the right 4, so 1, 2, 3, 4. And then the y coordinates 5, so you've gone over 4, then you'll go up 5 from there. 1, 2, 3, 4, 5. Which would be right about here. That would be the point 4, 5, right about there. So we found our point. Now, what quadrant is it in? We are definitely in the first quadrant. So there's your answer. The point 4, 5 lies in the first quadrant. Okay. Some characteristics of each quadrant also. The first quadrant, x is always positive or greater than 0, and then y is always greater than 0 also. So your x and y coordinates are both positive. They're both greater than 0. Now in the second quadrant, your x coordinate is less than 0 or always negative, but your y coordinate's always greater than 0 or positive. Then in the third quadrant, well, both are negative. X is less than 0 and y is also less than 0, so they are both negative. Then in the fourth quadrant, your x is always positive, but your y is always negative, because x is greater than 0, y is less than 0 with those. So that's how you can also know what quadrant something lies in. Okay, let's plot the next point. We have 0. They're asking you to plot the point 0, negative 3. Alright, so the point 0, negative 3, that tells you don't move left or right at all, since it's 0 for your x coordinate. It's 0. But your y coordinate's negative 3, so then you just go down 3 from the origin. 1, 2, 3. Well, your point lies at 0, negative 3 there. Now, something to know, that if a point lies on the axis itself, if it lies anywhere on any of the axis itself or at the origin, it's not in a quadrant. It has to be off the axis or the origin. It has to be located off of them. If it's on the axis at all or the origin, then it's not in a quadrant. Here, let's redraw this part. Since I kind of disrupted it by drawing there, but I had to illustrate the point. Okay. How about the next one? 4, negative 2. So you are being asked to plot the point 4, negative 2 and then identify which quadrant it's in. So Of course, this tells you here you're going to go over from the origin. You'll go over 4. 1, 2, 3, 4. Then you'll go down 2. From there, you'll go down 2. 1, 2. So it looks like your point here is 4, -2. What quadrant does it lie in? Well, this is the fourth quadrant, so your answer is the fourth quadrant. And I'm using Roman numerals for quadrants for a reason, because you're already using regular numbers to plot your ordered pairs and to write them out. So Roman numerals makes it less confusing when you're talking about what quadrant. Because if you had a 4 here, then 4, -2, it might look like, where's that extra 4 coming from? So if you get what I'm saying there, that's why I'm using Roman numerals to label the quadrants. Okay. We got the point here, -5, -5. So we're being asked to find the point -5, -5. So this tells you that from the origin, you'll go to the left 5 since it's negative. So 1, 2, 3, 4, 5. And then from that point, you'll go down 5 since the y is also negative. So 1, 2, 3, 4, 5. Right about there. So the point -5, -5 lies here. And then the other part of the question is, what quadrant does that point lie in? Well, it gives it away right here. We're in the third quadrant. Remember, first quadrant, second, third, fourth. It goes counterclockwise. So this point, -5, -5, lies within the third quadrant. Okay. Now, let's also go ahead here. Let's see if we can find a point in the second. Yes. We would have the point -5, 1. So we got to find the point -5, 1. So, of course, we're going to plot it. Well, this tells you that from the origin, your x-coordinate, you're going to go left 5. So 1, 2, 3, 4, 5. Then you're going to just go up 1 from that point. So there is -5, 1. So we got the point -5, 1 right here. Now, what quadrant does it lie in? Well, first, second, third, fourth. We are in the second quadrant. That's the point that -5, 1 lies in. Alright, so I'm pretty sure everyone now gets how to plot points and identify which quadrant we're in. That's pretty straightforward. Now we're going to deal with some relations between x and y. Because last lesson we did on the coordinate system, we just had a set of ordered pairs being a relation. Which, yes, that is in fact one form of a relation. That's all fine and dandy. But there's another type where you can have an equation of x and y. For example, you're given the equation x plus y equals 4, right? Well, what you got to do is set yourself up a table of at least 4 values. So one side will be for your x values, the other side will be for your y values, okay? Pick any number you like for x. So we'll say x is 0. I like to start at 0 a lot. So what you're going to do is substitute 0 in for the x in that equation, but you'll have plus y is equal to 4. Well, 0 plus y is y. Well, that tells you that y equals 4. So when x equals 0, y equals 4. Simple enough, right? Okay, how about, let's do the opposite. Let's make y 0. So you'll have x, and then we'll substitute 0 in for y. That'll equal 4. Well, x plus 0 is just x. X would equal 4. So when y equals 0, x equals 4. Okay. Now, let's pick -1 for x. So we'll substitute -1 in for x plus y equal to 4. Well, to get y by itself, we're simply going to want to add 1 to both sides to get rid of that -1. You add 1 to the left side, you'll just get y by itself, but you got to add to the other. 4 plus 1 is 5. So when x is -1, y is 5. And then we'll pick +1 for x this time. Let's pick +1. Well, let's see. So we'll substitute 1 in for x. So you have 1 plus y equals 4. And then you want to get y by itself, right? So you'll just subtract 1 from both sides. You subtract 1 from the left side, you'll get y is equal to 4 minus 1, which is 3. We could take it a step further. We could know that when x is 2, y would also be 2, because 2 plus 2 is 4. In fact, we'll use that. Let's use 2, 2. I think that'll prove a nice smooth connection. We'll have a fifth point. But when x is 0, y is 4. These table of values here, these become your coordinates for ordered pairs. So 0, 4. When x is 0, y is 4. So 0, 4 right here. When x is 4, y is 0, so you have the ordered pair 4, 0. When x is -1, y is 5, so -1, 5 right here. And then when x is 1, right here, y is 3. 1, 2, 3. All right. Now, all we got to do is connect the dots. Because we're being asked also, what relation does this form? That's a horrible line. Maybe I drew the graph a little bit skew also. Sorry, guys. There you go. We have just formed a nice, not so pretty line. So, whenever you play connect the dots and connect the dots, you get a line. So that's the relation that forms. This is how you may have looked through a lot of math textbooks or have seen lines graphed on these axes before, graphed in the coordinate plane. This is how you come up with a line. You just plot a bunch of points and connect the dots. That's really about it. Alright, 1 second here. I'm about to draw the points back in where I crossed the axis and had to erase it. Okay. Let's find the next, let's do the next equation here. Alright. Let's say we have y equals x plus 2. So y equals x plus 2. Well, again, we can let's make out a table of values here, okay? We'll have x and y. So, let's pick x equals 0. Well, when x equals 0, you're just going to substitute that into the equation. So y equals 0 plus 2. Well, what's 0 plus 2? That equals 2. So y would equal 2 at that point. Alright. Let's pick x equals -1. So then you'll do y equals, we'll substitute -1 in for x, -1 plus 2. -1 plus 2 is in fact +1. So when x is -1, y is +1. Let's do another one here. Let's say x is -2. So we'll do y equals, we'll substitute -2 in for x, -2 plus 2. What is -2 plus 2? That's 0. So when x is -2, y is 0. Let's do one more point just for good measure. I like to have about 4 points, at least. Let's make x +1 this time. So y will equal, we'll substitute +1 in for x, 1 plus 2. So then 1 plus 2, as we know, is 3. So then y would be 3 when x is +1. Alright, so now these table of values that you've plugged in, these table of values, each set becomes your ordered pairs. So 0, 2, you'll have the ordered pair 0, 2. So here's 0, 2 because you're going over 0 but up 2. -1, 1. Well, here's -1, 1 right here. -1, 1. -2, 0. Just over to the left 2, up 0. Then you have 1, 3. So here's 1, 3 right there. And then at this point, well, just connect the dots. You'll get a nice line here. We have a line that formed from connecting the dots. So that's what y equals x plus 2 looks like on a line form. I feel like we should do 1 to 2 more. Alright, what do we got here? Redraw my, where I messed up. Redraw it. Okay, we have the equation y equals 2x. So this time we got y equals 2x. So what we got to do here, do yourself a favor, form another table with x and y, form another table of values. So let's pick x equals 0. When x equals 0, we'll set that y equals 2 times 0 because we're substituting in 0 for x. Well, 2 times 0 is that, 0. So you would get the point 0, 0 whenever you have x equals 0. Let's pick x is equal -1. Alright? So you'll do y is equal to 2, then we substitute -1 in for x, so you'll have 2 times -1. So 2 times -1, that's -2. So y would be equal to -2. Alright, this time let's do +1. So y would equal 2 times, we'll substitute +1 in for x. 2 times 1 is 2. So you get the point 1, 2. Then let's just, for good measure, do one more. We'll pick x is equal to 2. So you'll substitute in 2 for the x, so you'll have y equals 2 times 2, which we know happens to be 4. So you'll get the point 2, 4. Okay? So now you have yourself 4 ordered pairs. You have 0, 0, which is right at the origin. So we color in the origin. You have the point -1, -2. So here's -1 down 2. We got -1, -2. We have 1, 2 right here. Then we have 2, 4. So go over 2, up 4 right there. And then you just play connect the dots again. Play connect the dots and you have a nice line here. So that's how you can graph lines. And there's other things too. Once we get more into algebra and other courses, you'll be able to graph all kinds of things. lines. You could even draw a closed figure such as triangles by connecting dots. It's actually quite amazing what you can do when you connect the dots, some of the things that you can draw. So that was it really for the coordinate system for now. We will definitely do more lessons in the future on it, but that's it for today. The very next lesson we're going to do is on the distributive property. So I hope everybody's ready for that, and I hope everyone has a good night. Take care.